Have you ever just looked at a huge desert landscape, with those incredible rock formations and just dunes for miles, and thought, how did this get here? Who sculpted all this? Well, today we're talking about the artist you can't even see, but whose work is absolutely everywhere, the wind. All right, let's dive into this masterclass in natural engineering. And just to get a sense of the scale of this artist's workshop, get this. About 1/3 of our planet's entire land surface is desert. That is a truly massive canvas, constantly being shaped and reshaped by the forces we're about to explore.
So here's our game plan. We'll start with what a desert actually is. Then we'll look at the recipe that makes it the perfect place for wind to work. After that, we'll see why wind is the top dog here, uncover its three main tools, and finally, watch that erosion in action.
Okay, first things first. When we talk about a desert, the one word you really need to remember is aridity. Dryness. That is the single defining feature of these amazing places. And they aren't just sprinkled randomly across the globe. Most deserts are found in these really specific bands, both north and south of the equator. And that's no accident. It's all thanks to global air patterns. It's the reason why legendary places like the Sahara, the Atacama, and the huge Australian desert all sit right in this zone. Now, for the wind to become this master sculptor, it needs the perfect setup, the right canvas to work on. So let's take a look at the very specific recipe for creating a desert. It's really a combination of these 5 things. You get very little rain, and the rain that does fall just evaporates almost instantly because of the crazy temperatures. This lack of water means practically no plants can grow to hold the soil together. And to top it off, you often have cold ocean currents nearby that stop moisture from ever reaching the land. You mix all that together and bam, you've got a dry, exposed landscape just waiting to be shaped. And not all of these canvases are the same. The wind gets to work on all kinds of surfaces. You've got these vast oceans of sand called ergs, flat rocky plateaus known as hamadas, and even gravel-covered plains called regs. This variety is exactly why we see such an incredible range of sculpted landforms. So this brings us to a really important question. See, in most places on Earth, water does most of the heavy lifting when it comes to erosion. So what makes the desert so special? Why does wind get to be the star of the show here? Let's just ask it straight up. In a world of solid rock and endless sand, what gives the wind so much power? And this breaks it down perfectly. In a humid place, right, you've got tons of plants acting like a shield, and all that moisture makes the soil heavy and clumpy. But in the desert, it's the complete opposite. The soil is totally exposed, it's light, it's loose, and there's absolutely nothing holding it down. The wind can just go to town, picking up and moving anything that's not tied down. Okay, so if the desert is the canvas, what tools does our artist use? Well, wind erosion isn't just one simple thing. It's a whole process carried out with 3 very distinct techniques. These are the 3 main tools in the wind's toolkit: deflation, abrasion, and attrition. Each one does something unique, and together they're responsible for literally every sculpted feature you see. Let's break them down. So first up is deflation. The easiest way to think about this is just large-scale removal. It's the wind acting like a giant leaf blower, just lifting and blowing away all the loose sand and dust. Over a long, long time, this can actually lower the entire surface of the land, carving out huge hollows. Next, we have abrasion, which is sometimes called corrasion. Now, this is the really cool one. This is the sandblasting tool. The wind scoops up tiny, hard sand particles and just blasts them against rock surfaces. It's basically nature's sandpaper, slowly scratching, polishing, and wearing away solid rock. And finally, there's attrition. And this is where it gets really clever, because this is the process where the tools sharpen themselves. As the wind is carrying all those little bits of rock and sand, they're all crashing into each other. These collisions break them down, making them smaller and rounder, which in turn makes them even better at, you guessed it, abrasion. All right, let's get to our last section and see how this all comes together. We're going to focus on the 2 big ones, deflation and abrasion, because they create the most dramatic and recognizable shapes. Now, this quote is the key to understanding abrasion's signature move. Because the wind can't lift the heavier sand particles very high off the ground, most of that sandblasting happens near the base of a rock. This constant undercutting is exactly how you get those amazing mushroom-shaped rocks you see in photos. This lays out the difference so clearly. Deflation is all about removing loose stuff and lowering the land, creating things like deflation hollows that can eventually fill with water and become oases. Abrasion, on the other hand, is about carving solid rock by sandblasting its base, which gives us these incredible sculptures, like rock pedestals.
So here's the bottom line, nice and simple. The process, deflation, has a direct result, a deflation hollow. Same goes for abrasion. It leads to a rock pedestal. The artist's technique directly determines the final sculpture. It's this really powerful one-to-one relationship between cause and effect. And the thing we have to remember is that this is a very, very patient artist. This stuff doesn't happen in a year or even 100 years. We're talking thousands, even millions of years. Grain by single grain, the wind just keeps working, tirelessly carving and shaping entire landscapes on a scale that's almost hard to wrap your head around. Which kind of leaves us with one last big thought. I mean, if a force as gentle as the wind can literally carve solid stone and move mountains of sand, what other slow, invisible, but relentless forces are out there